Hi students. Now in this session we will be discussing Unit 2 in FPGA architecture applications, the design examples using programmable logic devices and current state missions. This session is with respect to digital principles and system design, in which in the previous semester we would have been solved some problem with respect to EFSM. Design of clock sequential circuit, which is synchronous for JK flip-flop. So we are going to design a clocked synchronous sequential circuit specifically by using JK flip-flop. Now here it's a question which has been displayed. So we have four different states: 0 0, 1 1, 1 0 and 0 1. First, we have to identify how many number of states which has been encircled, and each state look for the arrow mark to which state it is going, with the numerator and the denominator as input and output. For example, 0 0 goes to same state 0 0 when the condition is numerator is 0 and the denominator is 0, 0 by 0, and it goes to the state 1 0, the next arrow mark, with the numerator 1 and the denominator is 1. Like that we have to look for all the different states how it is going. Once it has been seen, we have to formulate a state table which includes a present state QA QB. So we have four states: 0 0, 0 1, 1 0, 1 1. Next state, it's QA star and QB star when the numerator x is equal to 0, and QA star QB star when x is equal to 1, with the output when x is equal to 0 and when x is equal to 1. For the first case, 0 0 goes to its same state 0 0 when the numerator, which is nothing but the x is equal to 0 by output. So here we have 0 0 going to its same state 0 0 when x is equal to 0. The 0 0 goes to 1 0 when the x is equal to 1. Next, 0 1 goes to 1 1. So 0 1 goes to 1 1 when we have x is equal to 0, and 0 1 goes to 0 0 when the x is equal to 1, the output is 0. So like that we have to formulate for all the different two states. Once it is done, we know very well the excitation table of JK flip-flop. Present state 0, the next state Qn plus 1. When present state Qn is equal to 0, next state Qn plus 1, the J input value is 0 and K input value is x. If Qn is equal to 0, Qn plus 1 is equal to 1, J is equal to 1, K is equal to x. When Qn is equal to 1, Qn plus 1 is equal to 0, J is equal to x and K is equal to 1. When Qn is equal to 1 and when Qn plus 1 is equal to 1, J is equal to x and K is equal to 0. Based on the excitation table, we have to formulate the transition table, which is derived from the state table. It is also called as function table. Here it's been displayed. Flip-flop inputs are filled by using excitation table, in which we have discussed the previous slide for the corresponding flip-flop. So for the first, let me describe the present state QE, QEP 0 0. When my x is equal to 0, it moves to the next state QA star QB star as 0 0. So we have to refer the flip-flop excitation table. As in the question it was mentioned as JK flip-flop. So QA QA star JA KA, QB QB star JB KB, and we will get the respective output. Here is the display over here. Once it has been formulated by using the excitation flip-flop, we have to go for K-map simplification to find JA, JB, KA, KB, and we have to go for mapping, as we know already. Here we get the equations for JB and KB, like J and K, and it's an K-map for output equation y. So y is equal to, at last we get qa x bar plus qa bar qb bar into x. Once this has been received, we have to go for the last step, logical implementation of sequential circuit. Here, input and output are considered as x and y respectively. Output y is a function of present state qa and qb as well as present input x. So it is a melee model. So two JK flip-flops are used. Those are JK flip-flop A and JK flip-flop B. So the last step is the logical implementation of the given sequential circuit by using JK flip-flop based on the K-map simplification expression what we have received. Thank you.